Yeah, we're seeing slow responses here too. It looks like maybe we're approaching our SLO percentiles. I'm just getting to my desk to check. Let me get back to you. Walking, all right, yeah, we're seeing slow responses, huh? Let me see. What is going on here? Seems the web app pod is pegged to its CPU limit. Because this is a critical workload, I know we allocated 150% extra CPU capacity for this pod. But it looks like it's hitting its limit. Let me increase it temporarily while we see what's going on. Okay, I'll bump the deployment to the latest image. That should help as it's even more efficient now. Coming up online. All right, let's monitor the workloads. Let's see here. Okay. What? No, it just swallowed all the extra CPU I just gave it. Oh, crap. Okay, it seems like it's exfiltrating data. Oh no, I think it's mining crypto. But why? Where? This cluster is really hardened down. What's going on? Oh my God.
No need to worry, we're here to help.
Oh my gosh, El Seguro, is that you?
That's me, Stacey, but are still not deported.
Oh my gosh.
What seems to be the problem?
So my app deployment seems to have been pawned. Apparently someone is breaking into my container. It starts crypto mining shortly after my deployment is ready.
Let me see what I can do. All right.
Well, so I don't understand because my network policies restrict all incoming access, all credentials are handled in a secrets manager, pods run unprivileged, and RBAC is quite restrictive. All internal traffic uses mTLS. How are they getting in?
All right, let me check that container image. All right, okay. Let me crack open the container image and see what's in it. All right, I see. So it seems that your image has a malicious payload. Let me check. How are you building your image?
Well, here's the pipelines. You can see this app is building the image.
Okay. All right, I see the problem. Apparently, the compiler image you're using to build your project is compromised. Someone pushed a hacked version into the registry modified to inject the crypto miner in your app.
So it's my code's fault?
Oh, no, your code is totally secure. By the way, your Kubernetes security jobs are amazing. The malware is flowing through your software supply chain. It means that your dependencies are compromised, but nothing is actually checking them.
But I have a vulnerability scanner, and it shows 0 CVEs.
Oh, yeah. So in this case, the scanner will not help. Your image has 0 vulnerable components, so there is nothing to report. It's effectively 0 CVE malware. Let's see what we can do. All right. Let's protect the builder image by creating a SLSA attestation. We also guard the source registry, the source integrity with the SLSA source tools. All right. Next, let's harden the build by verifying the provenance of the builder image and the commit we're building at with an ample policy. And we'll check both attestations. Now let's add some signing to your images with Sigstore. And we also build a provenance attestation for your build image. Now let me enforce another policy to verify your attestations before pushing the shiny new app image.
Makes sense. We don't want to push things that don't smell right.
Right. Finally, let's attach assigned policy results and a VSA to your image.
A VSA?
Right, verification summary attestation. It's a type of statement that we can use to let our cluster know that we've done our homework and had ample verifier, builder, and source. That way, we can block the deployment if things are out of place. But we are guarding your app much, much earlier. Okay. So check this out. Let's try building the app with a compromised image.
Oh, awesome. It's now blocking the build process from using the compromised image.
Precisely. The build process refused to run because the compiler image failed the SLSA policy. Now let's block any malicious images from reaching the cluster. We'll write a Carabiner policy to evaluate the MPL results we're touching with cosine, and then we'll try to run the compromised image. Let me apply the policy real quick. There it goes. Now let's try running it.
Ah, awesome. The malicious image is now rejected from the cluster.
Exactly. Now let's run the image with the spiced up SLSA image.
Nice. It's in. Thanks so much for stepping in, but who is behind all of these wonderful security tools?
Well, so I'm part of a secret cabal of heroes called open source maintainers.
Whoa, wow.
For years, we have been working in the shadows, developing security technologies to protect against the threats attacking open source. Not only open source, but all software in the world. We monitor evolving threats and develop technologies like SBOM, Sigstore, SLSA, and more. They form the arsenal to defend against the evil forces out there. Whenever there is a new threat, we jump into action to protect and defend. Our project protects all stages of software development lifecycle against the scariest threats. And we are always working together to secure the software supply chain.
But all of this seems so hard. No wonder we need superheroes.
Well, actually. Hold on. We are just developers just like you.
Oh.
The only difference between us and you is that we're focused on solving security problems, while you, as you should, are focused on your daily work.
Well, I do, but I also need to run secure development cycle. Unfortunately, this is so overwhelming. There's a lot to do, and I sometimes don't know where to start.
Yeah, we understand that. As regular developers, we are also burdened by the load of securing our own projects. That's why we not only try to make our tools easier to use, but we also now have Baseline.
Baseline?
Right, the open source project security baseline, a framework that establishes concrete actions to secure your project. It's a perfect map that tells you where and when to deploy these technologies and best practices to keep your code safe and minimize risk.
Ah, so it's all of you security projects working together as a team, like the Avengers.
Exactly, but instead of muscle characters, it's all computer nerds working on projects like you. So, for example, let me show you. So this was your project before when I got here.
Okay.
And this is what it looks like after we applied a couple of basic SLSA principles.
Oh, this looks much easier to handle now, but I don't understand. We only made like 3 or 4 changes.
That's right. Security projects protect you in many areas tracked by baseline. That's what just by putting in, a little SLSA spice across so many of the baseline controls.
That's pretty cool. I mean, that means that as I build actual security, compliance just comes naturally.
It's perfectly said. Well, it sounds like you're ready to join our secret cabal of security heroes.
I'd love to. Where can I find out more?
Well, start by visiting baseline.openssf.org to get started. The secret is not having superpowers, it's just having a map.
So security isn't about doing everything all at once.
Exactly. It's about taking incremental steps in the right direction. Each control you implement makes you stronger. Each attestation you verify closes another door to attackers.
I guess that makes us all potential security heroes.
Now you're getting in. So it doesn't stop there. The baseline deals with other risk categories. The framework defines 8 control families that ensure projects are sustainable, well-documented, and have sound governance practices. Other areas of cybersecurity, like vulnerability management and security assessments, are also covered.
But why would you include things like licensing or governance in a security baseline?
Well, open source projects become part of products and projects everywhere. So a well-defined governance process ensures that changes and new features that are implemented into the projects are well reviewed and discussed in a community before flowing down to downstream consumers like you. And also ensuring that projects have an open source license ensure that whenever a project has new security features, you can keep using and updating in the future.
Okay, and the baseline has levels?
That's right. So baseline has 3 levels. Think of them like stairs. Start where you are and then climb when you're ready.
And what's the difference?
So level 1 is the foundation of baseline. It establishes principles like protecting your main branch, using MFA, actually things like you probably are already doing. So it's for any project, any size. Level 2 is for projects with regular users. Now, at this stage, you're signing releases, running automated tests, and handling vulnerability reports like a pro.
So do I pick my level based on how good I am at security?
No. You pick based on the maturity and usage level of your project. So if you're a single maintainer project, you can start at level 1. And if you're a library with thousands of dependents, maybe it's time for level 3.
Okay, so the levels grow with my project.
Exactly, and those security tools that we use, they check for requirements across all 3 levels. So you're building real security and not just ticking boxes.
All right, I'm ready to start climbing.
Great, and don't forget that we are all part of the OpenSSF, a community of developers, security folks, and organizations working together to secure open source.
But I'm not a security expert.
No worries. So many of us weren't either when we started on this journey. That's why the OpenSSF has working groups. Pick what interests you. So want to learn best practices? Join best practices. If you care about AI security, there's a group for that. And want to help build baseline and AMPL and other tools like that, check out Orbit. Or help identify secure the most critical projects everyone depends on.
Okay. So I can contribute at any level.
Exactly. So show up to a meeting, join the Slack, submit an issue, review a document. Every contribution counts. We're all volunteers making open source safer together.
No cape required?
No cape required, but you may need this.
Yeah!
Welcome to the cabal, Stacey.
Woo! And before we leave, I just want to do a couple of quick mentions. So Merge Forward is a new initiative creating diverse, supportive communities and ally networks for shared learning, mentorship, friendship, and collaborative idea exchange. You can find Merge Forward and all the community groups on the CNCF community page, as well as Slack. We're also hosting an LGBTQIA community gathering in the community hub today from 3:30 to 4:30. Where would any of us be without acknowledging the hard work of others? And we want to extend a huge thank you to Whitney and Lewis, whose Security Showdown talk at KubeCon a few years ago inspired us to make this comedic skit today. So thank you, Whitney and Lewis. I'm Stacey with the OpenSSF.
And I'm Puerco with Carabiner Systems.
And we'll both be at the OpenSSF booth number 1642 near the Project Pavilion. If you want to chat with us, you can find us there. Thanks so much.
Thank you.